Okay, per the request of another student who's unable to make it today, I'm going to record this session. I'm going to submit the recording for him in particular and anybody else who may want it. Okay. So, just a second. We're going to be discussing Linux today. This distribution is Kali Linux. If you're completely new to Linux, I'm going to show a few beginner commands. Not every brand of Linux is going to look the same on an operating system. There are certain Linux that don't even have a graphical user interface. It's just syntax or a command line interface. But more modern brands of Linux will have a command line interface and a graphical user interface. So we'll go to the command line. Pull that up. There we go. So this is the terminal. If you've ever used the command line or CMD, command line, command prompt, and other various names for it on Windows, it's pretty similar. With the exception of the commands, they're both command line interfaces, but each are different. Your CD is your change directory. Your dir on Windows lists your directories, but on here it's ls for list. If you do tac l, it lists things. If you do tac or dash la, it lists everything, including hidden. So we'll do a dash l, and as you can see, everything here is, populated in a list. Now let's say that I didn't put any kind of attribute like this right here, and I just do ls. It posts everything kind of clumped together in that format. It doesn't really give you any kind of details like it does over here. It doesn't tell you who the owner is, the group, or the size of the files or anything like that. Now, mind you, this Linux is actually one that I use for penetration testing. So you're going to see a lot of stuff on here that's different than you would on any other brand of Linux. Okay, so let's do like a ls.la so we can see the heading. And you notice that the list is much larger than the straight ls.tac.l. To tell if something is hidden, you will see a period before the username, kind of like on Burp Suite here. How it has a period right there that indicates that the file is hidden. In addition to using ls, you're going to notice some permissions over here. If it has a D as the first permission, that indicates that it's a directory. The first permission is for the owner, the second one is for the group, and the third is for every user on the piece or on the operating system. So RWX is read, write, execute. So for, let's say, the Java directory, we know it's a directory because of D. The creator can read, he can write, and he can execute. Any other user in the group can read, but they can't write, but they can execute. Just like every user on the system can read the directory, they can't write to it, but they can execute things from the directory. All right, moving on. I'm going to do an ls.l again, just to see what I have in here. And I'm going to see if I can change my directory to documents. So just like on Windows, you would do cd for change directory. And Linux is case sensitive, so I can't just type documents because it's going to tell me that it doesn't exist. Now if I do with a capital, it's going to let me change the directory. And if you do cd ... it takes you back to the previous directory. A little quick tip. If you're not wanting to type the entire thing, you can just do ls.l to show what's listed in your current working directory, and you can do cd. You can start to spell it and hit tab, and it fills it up for you. It's an autofill. If you're ever curious about which directory you're in, you can just do a pwd, which is print working directory, and it tells you, well, this here tells me that I'm in root. Okay, so you're gonna notice that I have a text file here called hey. If you're wanting to open hey to read it, you can just type cat hey.txt, and it tells you everything that's listed in that text document. Now, let's say that you want to add things to this text document. You've got a few ways that you can do it. You can type in echo, let's say test 3, and we'll make a new line, and we will append it. If I use 2 forward arrows like that, or less than symbols, it appends it, means it writes it to the end. So hey.txt, and we're going to run cat on it again, hey.txt, and you see where it added the test 3. Of course, since it's in quotations, it's going to put this little / in. So let's correct this. Let's remove that, and then type that. So we're going to do cat hey, going to hit the tab so we can autofill it, hit enter, and you see it added the other line next to it. I intentionally added the / in just to show that it just keeps appending to it. Now, let's say that I want to overwrite it and I want to completely remove everything from it. I can just type echo removed tests, and I'm just going to use one less than symbol to hey.text. So we're going to do cat for hey text, and you see that it removed it. Another way you can do this is by using text editors. They've got Vim, they've got VI, and they have Nano. I personally favor Vim, so I'm going to use Vim. I do Vim space hey.txt, and you see this is where the information is. This comes later in your course, or it can come later in another course. It's really good to learn how to use text editors. It's just like using like your Notepad or your WordPad on Windows, but this is more for CLI. You can also do it over here as well. So remove tests via Vim. Now cat hey, and you see it shows where I've made the changes. Or I can also just click here in the files. Let's see, hey, and see how it pops up here as well. This is the GUI, the GUI text editor. So we're going to close those two. Let's see. Let's say you want to make a file. So if you type in touch, we'll say hey2.txt, and notice it doesn't really give you any kind of indication that it was created. So you do ls.l to verify that it was, and you can see where it has hey2.txt. If you ever want to remove anything, it's just rm hey2.txt. We'll check it with lsl, and you see that it's gone. So let's say that you want to you want to write something in a file, but you want to create it at the same time. Well, the same thing as you would writing into an existing file. This is a new file, and we'll say that we're going to put it in. We're going to write it to hey3.txt. ls.l shows hey3. So we're going to cat hey3, and you can see where it created it. So we'll remove hey3. Another way you can do it is Vim hey4, and I for insert, so you can insert your text. This is another way to create a text file. Hit the escape key, colon, W for write, Q for quit, hit enter. So let's see if it exists. There's hey4. So we're going to cat hey4, and it says, you know, this is another way to create a text file. But it's interesting because you don't see a .txt, right? So let's go through our files here, and you see how hey4 looks like a text file, and hey.txt looks like a text file, but this one doesn't have the extension of txt. It's still a text file because it was created via BIM. Now, if you wanted to copy it, let's say we're going to copy hey4, and we want to send it to, we'll go to the desktop. Ignore the little less than symbol, it's a habit at this point. So CP means to copy, so I've copied hey4 and I've sent it to desktop. Anytime you're sending it somewhere, you can either do it that way, or let's say that I want to do txt just for the sake of the argument, and I remove that forward slash. Okay, so LSL, you see that we still have the two files, and we're going to do cd desktop LSL. See, there's hey, but you notice that hey4 never transferred, right? Because you remember when I typed in copy hey txt to desktop and hey4 forward slash desktop, right? Now, that's not going to work because I'm using the slash before desktop. Even though the slash is here, Linux doesn't exactly work that way. So let's say that I want to copy hey4 again, desktop. This means that it's going into the directory of desktop. If you do not have that, it's not going to, if you have it before the D, it's not going to go into it. So we're going to do that. We're going to go back to the desktop, and it should show it now. So there's hey4. So let's remove hey4, and let's remove hey text. We'll check and see that it's gone, which it is. We're going to do cd ... so we can go back. ls.l. We see the hey and the hey4 is still there. Now let's say that I want to completely move hey4, not copying it, but just cutting it out of this document and dropping it, and just, or not in this directory and putting it in a desktop, pardon me. You would type in mv for move hey4 to desktop. So ls.l shows that hey4, you see hey4 was right here before, now it's not. But let's do ls.l on desktop. hey4 is located in desktop now. You can perform any of these actions from any directory, providing that you give the path. So let's say that I want to remove hey4 from desktop. Whoops, that's my fault. Oh, desktop hey4. There we go. So as you can see here, this is what you call a syntax error when I've accidentally fat fingered a key. If you hold the control button and hit C, it sends a cancel code to the terminal, and it brings you out of that sub command. Now you see that I did like remove hey4. I'm saying I want to remove hey4 from the desktop directory, but it's saying that hey4 no such file directory. When you're using your remove function, if you're trying to do it in a different directory, you have to put the absolute path, in which case desktop is the directory and the file is hey4. So we're going to do an ls desktop just to verify that it's gone and it's no longer there. Sometimes you can type ls.l if you want it in a neat list. Sometimes it's just easier to just type in ls if you're looking to do it quickly. If you're just checking for files to see if files are there, you don't have all of the other information like the date and time and all that stuff. You can just see which files are located. So ls.a will do the same thing. It lists all. Let's go back to our root ls.a. You see that it still has all of your hidden files are listed. It just doesn't have all of the other information like this over here. All right, give me just a second.
I had to go get her ECU cup from the bookstore before somebody else decided to get it.
Oh my goodness. Okay, I've got this, I said, hello, Mr. Stiles, I'm in the learning lab with Ms. Dawn, and Caitlin helped me today as well upon completion of the book project for Module 1. Hold on a second. We submitted.
It was submitted. Here.
Okay.
Okay, so now let's say that you want to make a directory. Let's see, we're in root, right? Okay, we are. You would type in mkdir, and then you would just type in the name. So we'll just say test directory, test dir. We're going to hit enter, and then we're going to do an ls. Let's see, test directory is right here. So we'll go to test directory. There's nothing in this directory. But if you do LA, you see that you have two little hidden things that you can actually go back. Every directory is going to have these. CD dot, it's not going to take anywhere. It's just going to leave you at the same directory. CD dot dot takes you back to the previous directory. So, all right. So we're going to say touch. Actually, you know what? Let's do echo. This is a test file to utilize read commands. Read.txt. All right. Now, let's say that you want to do less. This probably isn't a good file to use it on, but we're going to try it anyway. Less read.txt, and you see that it gives you the very last thing in the file. You hit Q, it ends. You can do more, read.txt, and it gives you a bit at a time. That's what I mean by this, and this one isn't a good example. I'm going to remove the read, cd back, and if you want to remove a directory, it's rem dir, and you type in the directory name, ls.l, and you notice the directory's gone. Alrighty. Go C, Python, ls. We'll just do ls. Okay. cd documents, ls.l, nothing. All right, here we go. cd etc, ls.l. All right, so we're going to use one of these config files. We're going to use the UCF config file. So if you do more UCF, you see how it has everything up top, and it has more 70%. This means 70% of the file has already been read. Let's do less UFC or UCF config. If you hit the down key, it allows you to go down. If you hit the up key, it allows you to go up. Personally, when I'm reading files like this, I either use vim or I use less. Because if you just type cat ucf.config, it's just going to give you the whole thing, then you got to scroll up. I prefer just to use less because I'm able to scroll at my own discretion. This is a very short config file, so naturally it's not that big of a deal. But if you have a file that you're trying to read that has thousands and thousands of lines, then it can, be a little overwhelming. Let me see if I can find one that has a lot of lines on it. This is a relatively new VM, so I don't exactly have a lot on it. We'll use the system control config and ls sys control config. Okay, so you see how this one has a lot more stuff to it. Still not a lot. It's still just a few lines. But even this can be a little overwhelming if you use cat. So cat just throws everything up, everything at once. Cat usually takes it from the beginning and it drops it to the end. You can also use tail, which starts from the back and works its way up. Like you see how it just has just this little bit right here. This is the last. This is the last page of it. You can always use head as well if you're just looking at the first page, which is this here. And now we'll use more again, so you can kind of get an idea. Okay, so if you hit space, you see how it increases. This means you've already read 82% of the document whenever you get down to here. Hit space again, and it finishes the document and posts it or pastes it on the screen, prints it on the screen, sorry, just like cat would. All right. So ls.ltr is another it's another useful list as well. So you can see everything that's listed here from the ls.ltr. Now if I do ls.l, kind of looks similar, but there's a couple changes to it. So you notice that you can see here the time is listed, but it doesn't have the year. That's ls.ltr. This allows you to get a good timestamp of things without having to worry about seeing which year it is. If you do a ls.l, it doesn't give you a timestamp, but it does, however, give you the date. ls.ltr is really good if you're trying to troubleshoot. Oh, I reckon some of them do. Of course, those are shadow files. It's really good if you're trying to troubleshoot a system whenever you're investigating things in a forensics standpoint, or if you're trying to see when something entered or left your system. Those usually come in handy. You can see when things have been created, when things have been deleted. Everything has a log to it. But yeah, those are pretty much the basics. Those are the basic commands. You're going to use those quite a bit. Let's see. Let me see if I can find my sheet to my little cheat sheet here. Oh, here we go. One thing that you're going to use a lot is the help screen. I'm going to use ls as an example. If you do 2 dashes back to back and you type in help, it will give you your help file. This will show you how or what each command is, how they're used, and so forth. So like with this one, the usage is ls, and then you have your option, and then you have your file or your directory. Your A usually stands for all, shows doesn't ignore entries starting with the period, which is hidden. If you do a capital A, it doesn't list, the dot when it's just a dot or the dot. So let me give you an example on that. So ls.la, actually, let me go back to the root directory. ls.la, you see how this here has a dot and then a dot. Let's say you do not want those to appear. You can just do this. Oops. ls.l with a capital A, and you notice they're no longer there. Another way that you can usually look at help files for certain commands, you can always do man, we'll say ls. This will open up a manual file. You use the up and down keys to navigate just like you would with the ls command. This tells you which line you're on, you know, your pages, everything else. If you still need help, you can always just hit the H key, and it, you know, brings you to the help screen. Now, if you're looking for more, you just hit enter, or you can use the down key. If you're wanting to leave the screen, you just hit Q, and this brings you back to the manual part. If you want to quit this, you hit Q as well. Manual and help are going to be your two favorite things to use when you're learning Linux. It may seem like a lot to take in, but it's one of those kind of things that the more you use it, the more it starts to sink in. A few more complicating commands, or not really complicating, but advanced commands, I guess you could say. You can, if you want to show the current, date and time, these are system info commands. You can type in date. This tells you the date, the time, your time zone. Is it AM? Is it PM? If you're wanting to see this month's calendar, you can type CAL. Tells you the day, the date that you're sitting at on the calendar. If you type in uptime, this will show the current uptime, how long the system's been up. Since this is a VM and I started this maybe about 30-40 minutes ago, it's telling me that it's been up for 36 minutes. Only one user's logged in. To load average, this right here just tells you about the averages as far as like how much resources are being consumed. If you just type in W, this will tell you who's online. If I had a couple of other users online just on this server, like if this was a server, a CentOS server, and there was multiple users online, this would show all of the people that are online. But since it's just me, it's only going to show root. Now, if you're ever curious about who you are on the system, you can type in who am I, and it tells you right there. Another way to tell too is whatever name is before the @ symbol. Now, let's say you want to look up information about a certain user. So we'll say user root. So we're going to say finger root. This will give you information about this user. So to log in, for this user is root. The directory for that user is /root. Tells you how long they've been on. If it has any kind of email address or plans, it has it here. It shows you the shell that's listed for that user, and so forth. Now let's say that you want to look at your kernel information. You would use uname A, and this will show you your version and stuff. Your kernel's version. If it's 64 or 32-bit, it just gives you all the information about it. Tells you whenever it was last updated and so forth. Now, if you want to look at your CPU information, you can do cat proc CPU info, because the proc folder is all your processes, and this will give you everything that you need to know about your CPU information. These are good little commands that you can write down for future reference, but the more you use them, you'll pretty much memorize them. But the CPU info, it tells you how many processors are being used, the vendor ID, the CPU family, the model name, the stepping of it, and so forth. Tells you how many cores or siblings you have, CPU cores, the core ID, and so forth. Now, if you want to look at your memory, you can just replace the CPU with mem. And if you hit enter, this will tell you your total memory, how much you have on the PC or the terminal, or the Linux OS, sorry. This will tell you how much is free, and this is how much it's available. This tells you how much buffer's using, this is how much that's cached, how much is active, inactive, and so forth. A lot of this stuff here, you can find out what all this stuff means by just using the man mem info. And it tells you everything that you need to know in here. If you type in the H, it gives you more, displays more stuff. But this whole thing, it would take me hours to explain all that, so I'm not even going to get into it. I'm just showing you how the command works. I've already showed you the manual, which is man. Now, if you want to see like your disk usage, you just type in DF, and this will show you which disks or where it's mounted, the percentage that it's being used. This shows you in the form of kilobytes that it's used, how many blocks, how much is available. Usually if you see a /DEV, which is device, and a SDA or SDC, SDB, or anything of that nature, that's usually your partition. If you want to see your directory space usage, you can just do DU, which is directory usage, and it's going to load all of this stuff here. And you can see that it goes and goes and goes and goes until it lists everything. So I'm just going to cancel it with a Control-C. If you type in free, it'll show you the memory and swap usage. So this is the swap memory, and this is just the tangible memory. Let's say that I'm trying to find Python 3, because I use this thing for Python a little bit. If I want to find it, I just type in where is Python 3, and it will tell me where it's located. So like it says, Python 3 is in user bin, Python 3 or 3.5. So let's open up a, hang on just a second. Let's open up a new tab. We're going to ls.l. Okay, so we're going to do cd user ls.l. And where did that tell me it was at again? bin, cd bin, ls.l. And let's see if Python 3 actually is in here. You know what? This is a good way for me to show you the grep command. ls.l, if you do a pipe, well, hang on. ls.l, if you do a pipe, that shift and the key underneath the space bar that has this little guy, and you type in grep, and let's say I want to look for Python, I can do grep Python, and it pulls up everything that has the word Python in it. You're basically finding everything from this. So you can see that it has Python 2, Python 3, Python Ply, and so forth. But just to scroll up, let's see, Python, right there, from that. Okay, so we're going to say which Python 3, so it can show me which app will be run by. And it shows that it would be run, or from which directory. It would be run, or it would run from the directory of user bin, which is where I'm at in here. I think we got some time for me to go over some more. Let's clear that. Let's say I want to get rid of all this stuff on the screen. I can type in CLS, or sorry, that's one of those. I can type in clear, and it cleans up the screen. It deletes everything that's on the screen. All right. Now, if I type in ls.al instead of LA, this will actually show me the formatted listing with hidden files. And this is how this one looks, ls.la. It's not really much different, is it? It's pretty much the same thing. So it doesn't matter if you type in ls.la or al, it's going to give you the same thing. Now let's say that I want to see my processes. PS will show me the processes that are running, since I've only got 2 or active processes, because I haven't really done anything on this. I just booted it up just to show you some commands. These are the only 2 that are running. So if I type in top, it shows me all the top running processes. This is all the stuff that's running in the kernel. See, the top command's actually right here. My VM tools is right here. My name shell, terminal, and my shell. So we're going to hit the Q button to stop it. I'm not going to kill any commands or anything like that. But if you want to kill command, you would do type, or you would type kill and the PID that you want to kill. So let's say that I want to kill like VM Tools SD, I would just type in a 1442 because that's the process for that. I'm not going to do that because then my VM is going to shut off. Yeah, so compression and all that stuff on here is a little different. Usually you would use WinRAR, which is spell like that, or you use like a 7-zip file. Here you use a tarbals. It would basically just be file, whatever the file name is, .tar, .gz, or it can be bz2. But you would use like a tar, zsfv, and then the file name .tar.gz. This is how you would unzip files. This syntax up here can go in many different ways. If you're trying to extract things from a file, it would be tar xf because you're extracting the file from the file. If you're trying to create a tar with a gzip compression, you're creating a zip file, czf. If you're extracting a tar using gzip, you're extracting using the zip file. You're extracting zip file. If you're creating a tar with a bzip2, you're creating your bzip2 file. If you're extracting it, well, if you're compressing a file and you want to rename it, you would just do a gzip. You don't put tar. It's just straight gzip. Or if you're decompressing a file back, or you decompressing a file .gz back to a file, it would be gzip tac d because you're decompressing. But those are your compressions. You don't have to really worry too much about that right now. You'll have an entire chapter that introduces that to you. So don't let it give you a headache or anything this early, because a lot of this is new. A lot of this is going to be pretty confusing. I'm just giving you a rundown and some examples of what you can expect. Okay, so you're going to be doing some network stuff too. Like you got to ping and make sure that it can, communicate with other computers. So usually you would want to ping things. So we'll say, for example, ping. I'm going to ping Google's DNS server, and you see that it's going to keep pinging back to back to back to back to back. It's not going to stop because it doesn't have any metrics to stop. So Control-C is when you would stop it. Let's say I only want to ping it 3 times though. Let's type in ping tac-c3, and then we're going to select the host. It'll ping it 3 times and it'll stop. Now, let's say you want to get information about 8.8.8.8. You would just type in who is and then your host. This will give you all the information about that organization. So this tells me that the net range is from 8000 to 8127.255.255. Decider is a 9 rotation, which means it has 9 ones. You'll learn more about that in subnetting. It's nothing you need to worry about right now. It tells you the net type, which is a direct allocation. The organization, it's level, it's an LLC, it's a level 3 parent. Tells you the address of it, the organization ID, the city, the state provenance. So this is actually in Los Angeles. Let's see. This actually has a few comments that you can, like if you're just trying to get some information from it, it gives you a bunch of stuff like that. It looks like they got a bunch of org abuse handles and stuff like that, which is interesting because you don't really see that too much. But the net name is Google, G-O-G-L. It even says right here, Google LLC. It uses G-O-G-L because that's how Google is listed on the stock market. Just as an example, I'm going to click my Ice Weasel here, or I guess it's called Firefox now. G-O-G-L. So type in GOGL. And you see on NASDAQ that is GOGL. A lot of times you're going to see what it's called. Golden Ocean Group. Wow. Well, I guess I was wrong then. Guess things have changed a little bit. Of course, it says right here GOGL. Whatever. Anyway, so if you want to get DNS information about a domain, you would do dig 8888. This gives you all of your DNS information. Saying that I'm using Debian. Got answer, header, query, status, index domain, and so forth. Doesn't really give me a whole lot. Now let's say that I want to reverse look up a host. Dig x 8888. Let's see something real quick. Okay, I'm still connected. Usually it gives me a little more than this, but this just gives you an idea about what it does. Okay, so I think there's one more. Right, trace route. Let's say 8888. This will show you the path that it takes to leaving your router to Google. And whenever you see these little dots, this means that it's not transmitting. See, this is where I was saying that I wasn't, being able to communicate because it wasn't giving me anything up here. It's running into my gateway and then it stops. It's not leaving, which is no problem. Yours is going to be a little more different than mine is. Okay, so let's say that you want to log out of the current session. You just do exit and it closes your terminal. But this is about all there is to it. It's not really anything much more. So I'm going to stop sharing the screen. And I'm going to stop the recording because I think that's going to conclude this meeting.